This video is going to be a short refresher over graphing linear functions. So as we've seen in previous examples, the most important thing we need is a point and a slope. So in your previous classes, the focus was on slope-intercept form, y equals mx plus b, which kind of leads to the myth that you have to know what the y-intercept is. And that's not actually true. Any starting point will do, and then you can count rise over run from that point. It just kind of depends on the equation you've been given and what information you have. So a quick little refresher here. So if we look at number 10, in this case, this equation is in slope-intercept form. And so when we are in slope-intercept form, we can determine the slope, which for this equation is -2, and we can determine the y-intercept, which for this one is 3. The y-intercept is what we want to start with because we need a starting point to count from. So I'm going to start by plotting +3 on my y-axis. So that would be this point right here. Then the slope is the directions of how to get to another point. So -2, we need to think in terms of rise over run. So we can put that over 1. And since that is a negative, so again, I go up or down based on positive or negative, and then I always count to the right if I can. So in this case, I'm going to go down 2 and over to the right 1. Down 2 over 1. And we can keep doing that over and over again. Now, if you want to go in the opposite direction, we have to reverse everything. So instead of down and to the right, I would go up and to the left, up and to the left. And you don't need 5 points. You technically only need 2 points to graph a line, but it does help you draw it a little nicer. And especially if you have a straight edge, that's kind of hard for me on my iPad. But if you can use a ruler or the edge of your student ID or the side of your calculator, anything that'll help you make a nice, neat line, that's helpful. Now, on number 11, this might be kind of different than what you're used to. This one's not in slope-intercept form. So I could distribute the 2/3 and then add 3 to both sides. But if I recognize that this is already the point-slope form of the equation, I just need those two pieces. I have a slope of 2/3, and I have an x1, y1 of... Here's my y1 and here's my x1, but remember those are opposites. The equation looks like y minus y1 equals m times x minus x1. Anytime you have a minus in front of a variable, that means it's the opposite of the sign that you have. So if I look at this y1, I see a -3, but I want the opposite of that, so my y value is going to be +3. For my x1, I see a +1, but I want the opposite of that, so it's going to be -1. So that's the information I need. I have a point, -1, 3, and I have a slope. Instead of starting at the y-intercept this time, I'm going to start at the point -1, +3. That's my starting point. And then from there, I'm going to use the slope. Rise 2, run 3. Rise 2, run 3. Or I can go in the opposite direction. Rise -2, run backwards 3. However you want to do that. And so here is our line. That one was much straighter. Number 12 is weird because I only have one variable. And so whenever this happens, you may have learned this in Algebra 1, a good device to remember is HOI-VUX. It's like 2 made-up words. HOI-VUX tells you horizontal, 0 slope, y equals equation. VUX tells you vertical, undefined slope, x equals equation. I'm going to write that at the bottom of the screen so that you can copy it down if you'd like. There you go. So this equation has an x equals equation, so that puts me towards VUX. That tells me that x equals -3 is going to graph a vertical line, which has undefined slope. And so it's going to go through the x-axis at x equals -3. That's the point, and then the vertical line would go through like this. An equation like y equals 4 would go to 4 on the y-axis, and that would be a horizontal line through 4. So that's kind of the special cases. Okay, so that's a quick refresher on how to graph a line, and we're just going to do some practice on that now.